Talk a little about milk protein this morning. Again, an area where, certainly lots of focus, emphasis, not only genetic trends, management trends, right, et cetera, as Chuck pointed out, things like that. So what I'm going to do is you'll see kind of a blend of things here, right? And some of you have seen parts of this before. I've gone some more in depth in certain areas, but just maybe try to seed some thoughts in you relative to responses on milk protein out there in herds, relative to management opportunities, et cetera. Okay. So we're going to do a few different things, right? I'll quickly roll through. You guys have all my slides in your handout there. So again, based on various models, et cetera, what do some of the optimums look like relative to amino acids or field level balancing? What are some of the responses, right? We now have some research summaries out there that help give us some index here relative to what some of the responses have been across various studies and responses in general. And then I'm going to spend probably a little more time on this one right here and just talk a little bit about, are there, how long have we been balancing for amino acids out there in different ways, shapes, and forms? Pretty long time. Really, at the end of the day, I go back to sniffing, right? Even before, you're looking, 90s. Some of you were, I don't even think about how young some of you were anyway, right? But, some of you certainly remember, as do I, those times pretty well. But again, are there opportunities beyond that? Are opportunities to enhance responses to amino acid balancing and things like that? Because to some extent, it's really been very much a amino acid supply-centric model. And again, I want to give you a little context there and maybe try to seed a little bit of thought. And then if we have time, we'll spend just a few minutes on the transition calc because I couldn't help myself. Okay. All right. So, milk fat, milk protein. I think Ed Gallagher is going to talk about some of this certainly, right? And we know since we've gone to component pricing, that protein generally rules the day, right? Not that butterfat's not important, not that butterfat at different times. The protein here is in blue. This is dollars per pound of milk protein from basically 2008 up until early of 2015, right? So milk protein here rules the day. Sometimes, I put 08 in here and you put 2014 in here and boy, you get real high milk protein values, right? And it makes those economic opportunities really, really tantalizing out there. I think in general, we milk protein rules the day enough that our economics are going to be there, but certainly there are times when it's really tantalizing. Of course, milk fat here in the green, runs lower. I remember distinctly a couple of these times when milk fat got real high, and seemed like for whatever reason, I don't know if it's karma or whatever, but sometimes herds struggle. I remember some distinct times when butterfat prices get high, and herds have a heck of a time making butterfat, right? So it makes your jobs all relatively interesting out there, right? So I don't think there's any conspiracy there, but I think it is pretty interesting. And certainly there are times when milk fat certainly helps us as it did in 2014 as protein price came down, butterfat price comes up and helps to meter out some of the differences we see or some of the market swings, et cetera. Okay? All right. So, of course, as I think we appreciate, right, anything that increases milk yield, right, at the end of the day is going to also increase milk protein yield, right? And so, obviously we can play the percentage game, the yield game, or some combination of the two. But I think it's important to remember that those things that you do every day out with your dairies, right, that improve milk yield, right, are going to also increase milk protein yield, milk fat yield, et cetera. And so, you guys see some examples there. The short and dry period length, I only throw that one. I don't think that's a milk protein strategy, but it is kind of interesting that herds with short and dry periods or cows with short and dry periods, their milk protein content's probably 0.05 to 0.08 percentage units higher in the next lactation, basically same milk yield. Again, not a strategy to increase milk protein per se, but just kind of interesting biological phenomena there. Okay, and then we're going to focus again on the ration side here today. All right, Chuck Schwab put this together, schematic. You guys I've used this a bunch of times, and you guys have seen this a bunch of times in different ways, right, relative to protein metabolism in the cow. You've got the rumen here, you got the intestine, post-absorptive side over here, and certainly again, protein fractions here breaking down in the rumen, right, into peptides, amino acids, ammonia, given fermentable carbohydrate, incorporated microbial protein, and of course that true protein can also potentially escape, right, as RUP, and so we tend to think of RUP plus microbial protein, maybe a small amount of endogenous as that metabolizable protein. And of course, Protein side, right? It's use it or lose it, right? So again, absorbed, incorporated into milk protein, other body proteins, etc., or essentially deaminate. Of course, excess ammonia as well across the rumen wall. You get ammonia production in the liver, or ammonia detoxification of urea, in the liver. That urea recycles, right, both across the wall through saliva, and of course out in the milk is milk urea nitrogen, right? So again, you can use those as crude indices, of course, of the efficiency of protein use. All right, so again, we've been talking amino acids, a long time, right? This is the NRC 2001, lysine here, percentage of MP. The black dots here are where methionine was simultaneously higher, right? So again, seeing, especially when that methionine is higher, seeing these generally positive responses relative to milk protein content to lysine. Again, in the NRC, a break point here somewhere around 7.2% of MP. We see variation around that. Okay, methionine, similar story. Better responses when lysine is higher. Again, seeing that break point here, at least NRC calculated around 2.4. Again, lots of variation around that, right? So again, what is causing some of that variation? I think there's lots of factors for that relate to ability to predict, right? Different parts of, whether it's microbial protein or otherwise. It relates to digestibility, right, as sources. We know there are certainly differences out there, and Mike's work and others have shown nicely that that our RUP sources are not all created equal from a digestibility standpoint, okay? And also certainly just variation in the cow biology in different ways, right? So again, there's variation around it, but in general, seeing positive responses. Of course, we can also, and again, back to, but those numbers, right, kind of comes back, it depends on what model you're using, right? So Chuck Schwab, Nancy Whitehouse, I think it was collaborative with Tom Tolucki and the AMTS group as well, did some work looking at optimums here, amino acid concentrations in MP based on NRC, CPM, and then AMTS, NDS, or CNCPS 6.1 biology. So that's the immediate previous biology with a Cornell model. I think if you look here again, a little reevaluation in NRC, and you see some again, about 6.8 to 6.9 with lysine, percent of MP, about 2.3 on methionine. Still kind of that 3-to-1 ratio that we historically have kind of thought about. CPM, again, interesting, seeing fairly high optimums here for lysine and higher for methionine, maybe starting to come down a little bit. And then in 6.1, you guys see some numbers here relative to methionine, lysine. And then, again, kind of another theme here, still seeing that maybe that ratio coming down a little bit, meaning more methionine relative to lysine. Okay, so again, and part of that, too, is I think as we've really drilled on focusing on milk protein yield, et cetera. Okay? And then again, the 6.5 biology, which is the newest implementation anyway, MTS, NDS, somewhere around, if you think about milk protein yield, somewhere around 7 for lysine, 2.6 methionine, and then if you think about milk protein percent, maybe narrowing that even a little bit further. But still, again, kind of bottom line there is looking a little bit narrower in terms of lysine methionine ratio, things like that, right? Okay, so again, all right, so again, depends on what model you're using, where you're going to go. All right, enough of that, right? So let's look at some responses. Again, these are across wide varieties of studies. This was a meta-analysis that Bob Patton put together a few years ago, basically focused on the coated, encapsulated, rumen-protected methionine products. Again, at least at that point in time, the two major products that were out there. Had about 35 studies total, 75 diet comparisons, and they were feeding about 20 grams of stuff per head per day in these studies. Again, Sarah Schuling, she again put these next couple slides together. So even though it's Bob's data, to show the results here again, you got the average response here, the min and the max. Kind of pretty much equivocal for dry matter intake and milk yield, right? So very little average mean response. You see variation either side of that there. You certainly do see that roughly 0.1 in the data percentage unit increase in milk protein percent. So it's milk protein yield response driven mostly by milk protein content type responses, not so much by the milk protein or milk yield responses there. Again, some fairly wide ranges in responses, but you see in this case, you know, the quote unquote negative responses maybe even not all that much different from zero. You know, pretty much close to zero on the low end, and obviously some fairly high responses here on the high end, right? So again, data is showing pretty reliably getting a milk protein response with these types of products. Milk fat, again, on average, right, being pretty much equivocal here in terms of kind of basically a zero response. Some wide ranges there, though, probably on both sides anyway, relative to percentage and yield responses. Okay, so again, and I haven't really drilled into that too much. Okay, but I typically don't think about at least our protected methionine sources as being a milk fat driver in most cases, right? You think about them more from a milk protein side. That doesn't mean you might not sometimes get a response there, but again, this is the way I think about them. Okay. All right, Jeff Zanton. Jeff is now at USDA Dairy Forage Research Center, and he published this meta-analysis again last year. It basically looked at responses of cows, whether they were infused basically post-ruminally with DL-methionine, okay, and then you had the different or at least the HMTBA, right? So the analog of methionine here, and then two of the commercial protected methionine forms that he was able to evaluate from the literature. Again, what you see here, again, this is the base response to methionine. Again, you see a milk protein response here, okay? Pretty modest. You may argue a little bit of a milk fat response, but again, looks like milk protein is, again, kind of the major responder there. You also see, if you look here, between intake, milk yield, milk protein, okay, again, generally speaking, still picking up that nice percentage and yield response with the protected products relative to milk protein. Picking up maybe a yield response here with the analog, and so not seeing necessarily milk protein percentage response, but seeing some milk protein yield response, again, driven probably off of milk yield. And then milk fat, again, probably seeing more reliably a milk fat response with the analog compared to the protected sources. And again, I think that meshes reasonably well, I think, with what we see out there in reality. All right, so I'm going to switch gears. This is where I actually want to spend time, because you guys, you've seen all that stuff before, right? And you're probably, some of you are going to say, well, I've seen the stuff that's coming before too. But anyways, but what there's got to be more to this story, right? I mean, it can't just be let's set our numbers and our models relative to amino acids percentage of MP. Or just throw it in the diet, and whatever happens, right? So and hopefully we'll get a response. But what's going on here, right? Are there opportunities to enhance our responses out there in the real world? Okay. One of the things that's been around for a long time has been this notion that there's a linkage between energy and milk protein. Some workers here overseas, you see the date there, right? So really reported a much stronger relationship of milk protein with energy intake than protein intake, right? And I think kind of the traditional thought there, right, is okay, if we got more energy, right, means we got more carbohydrate, right, we got more microbial protein. We know microbial protein is a good source of amino acids, right, blah, 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 right? So it's kind of back to a rumen mindset here. And I think, that on some level that makes sense, because certainly we certainly think that and know, right, that sugar, starches, digestible fiber, right, drives microbial yield, right? So again, and in fact, even very recently, I heard, I was listening to a speaker talk about balancing amino acids and put amino acids in the diet, we create space, right? And so we use that space for fermentable carbohydrate, blah, blah, blah. Still very much a rumen-centric, supply-driven model, more so than maybe, again, thinking back to driving microbial protein synthesis, blah, 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 and maybe not so much a regulation model here. So back in the 90s, Dale Bauman, Dale's group did, and there's been some other groups that have done some of this as well, they were trying to look at milk fat, and they were trying to basically look at insulin, its relationship with milk fat. There's been some, kind of long-standing speculation that, part of the reason for milk fat decreases is insulin. I think now we understand certainly quite well all the stuff related to CLAs, unsaturated fatty acids, trans 10 cis 12 related, CLA related forms of these things. And so again, but at the time, right, they didn't know any of that, right? So they wanted to look at insulin very specifically. They did it using a procedure called the hyperinsulinic euglycemic clamp, okay? I'll show you kind of what that is here in a minute. It's a pretty good mouthful, right? Okay. But what they found at the same time was, you know, basically if they just kind of did this to the cows, they got about a 15% increase in milk protein yield. If they did it and put casein in the diet, or not in the diet, I'm sorry, abomasal infused casein, right? And I think when casein is a milk protein, you know, excellent balance, as you might expect, of amino acids for milk production. You know, a pretty large responses in terms of milk protein yield here. You know, again, if you think about, you know, what we typically might expect to see, I mean that, you know, let's say you get a 0.1 response milk protein percent with same milk yield, okay? That's about a 3% response, right? I mean, you know, again, so let's say you get 0.15 or 0.2, you're talking, you know, 4 to 6% response, right? So, but they're seeing, you know, 15%, you know, 25%, 28% here with branched chains. This was in goats. Brian Beckett, insulin or insulin plus amino acids, again, saw nice responses here. The challenge here, one of the challenges here is that these diets were probably arguably pretty deficient in protein and amino acids the way we kind of think about them today, right? Obviously, so they did get some nice responses with the casein and branched chain amino acids, but certainly got more response with the insulin. The other part of it is these cows were making probably 60 pounds of milk, right? So they weren't exactly, you know, setting the world on fire from some of these standpoints, but still pretty interesting, okay? Again, this is how it's done. Basically, put a bunch of jugular catheters into cows, infuse insulin into one of them, use the other one for infusion of blood glucose, and then you also sample as well. And so, you know, because again, if you just pop insulin by basically a 3 to 4x here, and you don't do anything to the cow, she's probably going to go into diabetic shock and die, which isn't really a great experimental outcome. Okay, even Gallagher gets that, right? So, hey Ed, how you doing? So, okay, all right. So infuse the, just showing the love. Okay, so you know, again, keeping blood glucose in a fairly narrow range. So again, they vary, right? They vary that infusion rate of glucose in these cows to keep that blood glucose in a narrow range, right? Okay, and that actually takes a lot of glucose, right? So they're infusing here, you know, I mean they're infusing a lot of glucose in order to make this happen, right? Okay, so interesting model, right? A couple things that are, you know, again, one is we're probably super physiological relative to insulin, okay? Second part of it is we're giving these cows a whole, or they, right, giving these cows, well, we've done these techniques too, a whole pile of glucose to make this happen, right? So we were interested in trying to bring it once, just to look at this in a little more physiological model. And this is some of Lori Winkleman's PhD work in our group. And we did some work looking at long-acting insulins and milk protein. And so this, again, this is a don't try this at home, right, approach. But it is relative to, you know, again, so anybody who's diabetic, right, or insulin-dependent diabetes may be taking one of these forms of insulin, right? There's a variety of different insulins out there in the market. We again chose a couple here to look at. Some of you may be familiar with, and we basically did this in you know, in cows in early lactation. We did a bunch of work initially to get our dose right, okay, right? Because we wanted to have a dose that would increase insulin in the cows, but not tip them over, right? Because we weren't going to give them any, you know, we had dextrose on the cart, but we never actually used it, right? We never actually had to use any glucose on these cows. So they tolerated it actually quite well, okay? And again, basically they were milked twice a day for 10 days, okay? Just show you our diets here, and again, this is all published in Dairy Science. Corn silage-based diet. You see that if you look at our supplementation, again, we certainly worked to try to make sure that we weren't limiting the cows anyway relative to either MP or amino acids. This was the pre-change good kind of aminoshure-m, okay, just for clarification there, and then a blend of a couple different methionine sources there, okay. See again our diets. We had the starch. We did have the starch level up there, probably a little bit on the higher side. Again, this is in kilos per day, so we're targeting pretty high milk yields here overall. And again, predicted supplies of lysine methionine. Again, getting up there. Again, the idea to make sure we weren't we want to make sure that at least we were feeding them in a way where we wouldn't hold back a response. All right, apologize. These are in kilos as well. But show you a couple things here. Our control, our two forms of insulin, a lot of numbers here. I apologize for that. Okay, basically no effect on intake or milk over the 10-day period. We did take these cows. These cows were making about 110. Do my conversions right here. They were making between 100 and 110 pounds of milk per day, and basically we took milk protein anyway from a 3 up to about 3.2 to 3.3, depending on what you're thinking about here, right? So pretty decent percentage increase here in milk protein. Interesting to us, milk fat also went up, right? We were not expecting that per se, but milk fat went up as well. And if you look at some things, MUNs came down a little bit. No surprise as we increased milk protein. Okay. If you look here over the whole experimental period, right? So days 2, 4, 6, 8, 10, or thereabouts. And again, here's the controls. Okay. And you see that that again we did get responses. One of the forms of insulin had a much better profile, lasting profile in the blood than the other, right? So they're not all long-acting insulins are created equal. The Humulin actually has a little more of a spike up front and then kind of tends to go down. The Lantus was more of an even. So again, we got better responses with the more even stuff, right? Again, so looking at MUNs again, see that decrease in MUN, with the insulin. So again, makes sense that these cows are doing a better job of incorporating or making protein. Okay. Interestingly, look at milk fatty acid composition here, and again, back to I told you we had some increases there relative to controls in the cows given the insulins, and looks like that's coming to some extent more through the shorter chain fatty acids than through which would be de novo in the mammary gland rather than the longer chain ones, right? So again, we don't fully understand that one, but it is interesting. And part of why it's interesting is some of you saw Dave Barbano's presentation last year here at the Nutrition Conference, where Dave's been doing a lot of work with looking at components and looking at fatty acid profiles in milk. Okay, and this is lots of farms anyway across Vermont and northern New York. And again, this would be Holstein farms here. This is percent protein. So see basically the very same correlation with milk fat content as well. And seeing here that these herds, right, that have higher milk proteins tend to also have higher de novo fatty acids in the gland, right? So again, is that an insulin thing? Is that the mammary gland's working better? I don't know. Is it that we've got the rumens right? Because we do know that when we get into a milk fat depressing type situation, that de novo fatty acid synthesis is depressed more so than others, right? So that could be part of it, right? So interesting questions here relative to, or is it just simply telling us something about the energetic status of that herd, right? Okay. All right, that's all great. Okay, well, what's our field implication, right? So the implication right here is that potentially, right, diets that may also help us on the insulin side a little bit, and these would be more glucogenic or propiogenic type diets, right, may support greater responses to amino acids, right? So you see, I've got a question mark there because I don't really know, right? Okay, I don't really know, okay, but I'll show you some data here that at least makes us think about that a little bit, okay? This was done up in Canada. A few years ago, they were doing, they were doing some duodenal infusions of casein and propionate. Of course, you infuse propionate, get absorbed, right? It makes glucose in the cow. We'll give an insulin, potentially an insulin response there. 4 treatments to control, duodenal infusion of casein. Again, that's That's a lot of casein, right? So that's 1.75 pounds of casein. Infusion of propionate here, again, a pretty decent amount of propionate there, and then the combination of the two. Okay, so if there is an if there is maybe not a statistical, but if there's a, you know, if this stuff holds true, right, you'd expect probably your best response here with that treatment in terms of milk protein and things like that. Okay. All right, let's look at what they did. These are it's a half udder study, again, an intense study. Looking here again, animals not you know, not cranking lots and lots and lots of milk. Okay, but again, you got the control here. Here's milk yield kgs per 12 hours. The milk protein parameters there. Casein alone, right? So seeing you know, seeing some responses with casein themselves, seeing also responses with propionate. They look to be additive. And so, because again, if you look across here, casein, propionate, and then the combination, again, you get nice milk yield in either the casein ones, get your best milk protein basically when you have the combination of the two. Okay, you know, certainly do see some milk protein response here in these cows with just the amino acid infusion, but again, seeing a better response with the combination. Okay. Work on Mark Hannigan's group, again, published a similar type study, maybe a little closer than the Canadian study anyway. Again, casein and starch here. Again, you know, fair amount of starch here infused post-ruminally. Again, I don't think this is not a, I don't think I'm making a case here for post-ruminal starch, just to revisit an old topic a little bit, right? I mean, I think, because again, you're going to get insulin responses through propionate as well in the rumen and things like that. So it may come back to fermentability. You know, some of it may come to intestinal, but I don't think we've really truly evaluated that. Okay, control casein starch, the combination. Right, look at their results here. Their intake responses here. They did see actually some increased dry matter intakes with the. Of course, that included the infusate, right? With the starch infusion. Of course, you got 2 kilos of starch there. Milk yield, again, seeing a starch effect there relative to milk yield. Milk protein, seeing a starch effect, but then an interaction where, again, seeing the most milk protein with the combination response than anything else. Milk fat, okay, in terms of grams per hour, you know, seeing more, you know, basically, well, pretty similar here. See maybe a little bit of decrease with the casein, again, some interaction there. You see, again, some milk protein and milk fat relationships there as well, right? But anyways, but again, in general, you know, suggesting that maybe there's something there as well, okay? So this is, again, this is from Van Amburgh, and so I think some of you know that he and Ryan Higgs have really kind of looked at expressing our amino acids relative to energy, right? And again, that's a real departure for us from where we've been, right? I myself am still gaining some comfort there, right? But biologically, to me, it makes sense that the two things ought to be, is that fading out? Okay. Okay, two things ought to be integrated there. Okay, I can also probably ditch the mic, right? And so, again, digestible lysine here relative to MP, okay? And again, this ratio of predicted to required, not predicting all that well, okay? It tightens it up when they put it on an ME basis, right? Same thing on methionine, again, tightens it up on an ME when you look at things on an ME basis, right? So just again, the work that Mike and his group have done, Ryan Higgs, et cetera, you know, relative to trying to kind of rework the whole amino acid thing, rework efficiencies of use. Those desperately needed some updating, and comparing it to, you know, doing some optimums here relative to grams of amino acid per mcal of ME, okay, and again showing pretty similar results from, you know, from their work versus some stuff that Alain Lapierre put out, okay. And also interestingly, you know, coming back to whether it's looking at grams of amino acid per mcal of ME, 3 for lysine, and then about 1.1, 1.2 for methionine, okay. What was interesting in Mike's observations is that, you know, you go back a few years to Chuck Schwab and Roquin's work, where they were talking about lysine and methionine as a percentage of the essential amino acids at the intestinal level, and you know these were the values they were coming up with at that point in time, interestingly enough, coming up with very similar values here using a very, very different approach. So kind of interesting to see these things kind of reconcile a little bit. Okay. All right, just going to end here. Clay, what do I have for time? Do I have a few minutes? 10? Okay. Okay. All right, it's either pass interference or it's 10. I'm not sure. Okay. All right. Amino acid supplementation, transition cow diets, right? Again, so some of you see me go through this before. You know, I put this in here because, you know, I think the data overall, I'm going to roll through it, I think in general support that we ought to be putting, you know, balancing amino acids beginning before calving and continuing into lactation. I think the production responses tend to be there. I talked last year about kind of differentiating. There are some out in the industry that kind of look, that kind of basically try to say that things like methionine and choline are equal in terms of what they do in the transition cow. I think it's pretty clear it's very different, right? Choline has a very specific role relative to liver fat metabolism. There's some new data from Heather White's group at Wisconsin-Madison. It's back on the back table. Luke will even probably wave and look all pretty back there and things like that and point to it. Okay, but I mean, no, but there's stuff there that, you know, yet at the same time we see production responses. The data would say production responses to methionine and transition cow diet. So I'm just trying to differentiate this two a little bit because they really do need to be differentiated. Okay. But I still don't see a lot of amino acid use in dry close-up diets, for example, and things like that. Okay, I do see some, but not a whole lot. Okay, and again, I think it remains an opportunity for us. All right, some old data, right? So this was probably one of the first studies done looking at methionine in transition cows. Actually, we weren't really thinking too much about transition cows at that point in time. But basically wanted to look at methionine supply beginning before calving. Not a real big study, but still 7 to 10 days before calving through 18 weeks after calving, 0 versus 20 grams per day by top dress. Okay, again, we just kind of threw it on. You know, pre-calving diet. You know, all cows were fed once daily a typical dry cow ration consisting of grass hay. Okay, so this would be about 11 pounds a day of grass hay, about 7 pounds a day dry matter corn silage, and then about, this would translate to about 9 pounds a day of a grain mix with corn, soy meal, mineral vitamins, and a pre-calving conditioner, which I'm not sure what the heck that is. But anyways, actually kind of looked like a controlled energy diet to some extent before there was such a thing, right? You know, frankly. But I'm sure we weren't chopping it well enough. But anyways, okay. So, but this is our entire description there, right? So nothing too sophisticated there. You look at our post-calving diet. Again, I laugh at some of these things. You know, alfalfa silage, corn silage, ground shell, you know, cornmeal, right? A little bit of soybean meal, soy hulls, right? University of Illinois used to get the soy hulls free from ADM, as Jerry knows, and so every diet at Illinois has soy hulls in it. Anyways, okay. Well, we appreciated it. How's that? Okay. And then some mins and vits from there, right? So again, you know, diet that I probably wouldn't feed today. You know, 25% NDF, right? Bunch of protein, bunch of RDP in there, almost no RUP to any meaningful extent, right? So, but again, didn't know much better at the time. So again, looking at responses here, despite that, right? Got actually, you know, got a milk yield, this was not significant here for milk yield. Milk fat, we did get a trend here. You start looking at the yields anyway of fat corrected milk. You know, they were higher anyway in cows fed the methionine supplement versus the control. All right, I'm going to breeze through some other stuff here. This is some of Mike Saha's work done also in the mid 90s. You know, they did show responses of cows to methionine plus lysine supplementation in terms of milk yield early lactation. Okay, didn't see a lot of response to methionine alone, but certainly saw responses when they put both together. Okay, some work out of our group. Again, this was the analog of methionine here, and again, seeing a quadratic. So we've got about 3 kilos of milk when we went to kind of what at the time we thought were the requirements. Milk yield came back down when we went to kind of super levels or super high levels of the analog here in this treatment. Okay, but again, where we might run in typical diets, maybe not seeing some milk yield response there in these cows in early lactation. Okay. Again, we looked at all the liver stuff here. Didn't see any effect on liver metabolism, things like that. But again, did see some evidence for some milk yield response with the analog. Okay. Some work out of Wisconsin, Rick Grummer's group. Again, they looked at the analog relative to liver triglyceride, et cetera. Didn't see any effect on liver metabolism there. Again, that was their restriction feeding model and things like that. Okay. Work out of Canada here, protected methionine with or without folic acid B12. In this case, didn't see a milk yield response. Did see a milk protein response here. Cows fed methionine beginning before calving. Actually saw an increase in liver triglycerides in this study. Again, really contrasting to the choline data as we talked about last year. Ryan Ordway's work, again at UNH, looked at the isopropyl ester of the methionine analog or protected methionine. Did not see any response relative to milk or fat-corrected milk. Did see a milk protein percentage response here with both the analog and the protected form of methionine compared to the controls. And then most recently, this is out of Illinois, Juan Luer's lab, and again, they basically looked at, again, the isopropyl ester or protected methionine. Saw nice responses overall relative to milk yield. No effects on, again, energy metabolism per se in terms of NEFAs, ketones, or triglycerides. And I've seen some more of this data since then. Again, there was some evidence of better immune function in these cows fed the methionine. There's also better evidence of better oxidative metabolism as well, higher glutathione concentrations, et cetera. So again, showing anyway, maybe not a classical, maybe not a liver energy metabolism response, but maybe an immune / oxidative metabolism response with methionine here in transition cows. And so this whole inflammation thing has gotten a lot of interest out there, relative to things going on in these fresh cows. Okay. So again, overall summaries, right? Again, I think certainly we do see some positive effects on milk yield, milk protein. Again, and I think it comes back probably to a limiting amino acid or immune function mechanism anyway. Okay. Just to summarize, and I guess we got a couple times for questions. Certainly our results, the results overall, I do think supporting balancing for lysine, methionine, and lactating cow diets. Our optimum ratios, especially in the we start thinking about component yields and things like that, probably come down a bit, right, from where they were traditionally. Certainly look to be some differential or different sources of methionine may give some, again, they're not all, they're going to maybe do different things in the cow, okay, especially differentiating between some of the analogs and the protected forms. Energy supply, though, again, back to let's not forget about this thing in terms of being kind of an integral part, I think, of doing some of this and getting good responses. And so, particularly fermentable carbs, I think, are an important factor modulating, again, those mammary gland responses in terms of milk protein and how well they utilize those amino acids. Again, don't forget protein synthesis, and I've heard Ben Amburgh say this a bunch of times, right? Protein synthesis is energy driven, right? So we can't forget about that in the whole equation here, okay? And again, we are intrigued by what's going on here in the mammary gland relative to having better, why we correlate, or Barbeno correlates better de novo synthesis of fatty acids with not only milk fat, which makes sense based on the CLA story, but also milk protein, okay? And then finally, amino acid supplementation beginning before calving. I think in general we're going to, we see benefits for early lactation performance. If you're looking for ketone responses and stuff like that, probably not going to see those, right? I don't think we've got good linkages there, despite suggestions that are pushing 50 years old now that there was a linkage there, okay? But certainly look to be a role there, and it may come back, whether it's limiting amino acid, whether it's immune function, whether it's oxidative metabolism, whatever. I mean, the data there are kind of building that whole area and showing maybe some opportunities. So, appreciate the opportunity. Any questions? Yeah, so Glenn's mentioning there was some work done. Mogens Larsen, who's in Denmark, had done, and I don't have the slides in this particular slide deck, but they did a really neat study in fresh cows where they basically what they did is they abomasally infused casein and beginning post-calving. And what they were trying to do was, of course, we not only, in addition to calculating it, we have a negative energy balance, right? We can calculate a negative protein balance post-calving as well for about the first 2 weeks after calving. And what they were trying to do was basically infuse casein in amounts to kind of wipe out that calculated deficit, right? So, and what they did was it was a really cool study. And what they did is I think they infused 360 grams on the first day of casein, 720 on the second day. And so infusing a pretty good, so that's, pound, 3/4 of a pound on day 1, pound and a half on day 2. But then what they did is they decreased the infusion rate every day thereafter, as the cow picked up her own intake, right? And they saw about a 15-pound milk response in those cows. And so got us really thinking, so there's a couple things there, right? So, one, I mean, that's a massive response, right? And to that protein immediately post-calving in these cows. Bless you. I talked to Mogans out at the Transition Cow the Amino Acid Discover Conference there in May or whatever, and they've repeated that now twice, right? And they've seen similar responses both, so it tells us that there probably is something going on there, okay? So one of the things that's going on, one of the things you think about that, of course, obviously you're supplying all amino acids, right? But one of the things that do tend to be higher in casein are things like branched chains and things like that. And we don't necessarily have great feed-based sources of some of those things. So so there might be an opportunity there, right, Griffin? So make you feel better. So again, makes us wonder. I think we've got an amino acid opportunity of some sort in these fresh cows, right? That's a bit different, a bit unique compared to where we typically are with conventional thinking on protein, amino acid nutrition and stuff like that. I don't know exactly what that is, right? But there's a lot of smoke in this area right now, research-wise, in terms of being maybe some opportunity there. And to take us to the point where I think we go 5 years from now, we may find ourselves, instead of these fresh cow diets being just kind of tweaks on a high cow diet, we may find us feeding some very kind of different looking diets, maybe first couple weeks after calving or something like that. And again, whether it's some of the fiber starch stuff that I'll talk about on Thursday at the conference, whether it's the amino acid protein side, because these are things probably we're not going to do for a we're not going to do these things once we get out into lactation. But I think there's an opportunity there in immediate post fresh cow, and we're getting ready to do some work in that, very specifically in that area. So, and I gave Griffin a hard time because there's no confidence. So they've been very good. They've been working with us to basically protect some amino acids for us. So I appreciate that very much.